Welcome, everybody in the lecture hall. Welcome, everybody on Zoom. Welcome, everybody from the future. Today, we are going to continue with the SQL part. It's a practical part, and I think it's probably going to keep us busy for 2 hours. So this is all we are going to be doing today. What's really nice about this is that everything that I'm showing to you, you can actually put in the Jupyter notebook, in the Docker that we prepared for you. And it just works. So you can actually try it out, experiment, see for yourself. If you have questions, you can directly write queries and see what happens. Who has actually already taken a look at the Docker and the past exams cheat sheets? Nobody? You can, right? So we have this what you call the exam magic box, which has all the environments of past exams and all the data, and you can just play with it and see the data sets that we had in previous exams. It just works. Okay, so I would like to ask you a question. Before we start, to check whether you followed, if I find the window, here it is. So, can you tell me, if I give you this table that is that I assume is in there in PostgreSQL with this name, and we would like the output right below it, AED bar to bar. I'm giving you 4 queries. Which one of these 4 queries gives me exactly these outputs, right? So that's the question. So you see one query on the screen, probably see it on also on your smartphone or app, but these are the 4 queries. So these are all select from where queries, right? So this is what we saw last week, select from where. So select ABD, there is B as E also, then there is where B smaller than C or greater than C. Then there is this is unknown statement, A equals D, so which is the correct query that returns the expected outputs. All these queries are fine, right? But they might return something different. So one way to do this is you need to look at the column names. It seems that there's only 1 row left, but there were 3. So which row did it come from, right? So what is the most obvious row that it could have come from? Then what could have been the predicate that actually selected that row? How did I get these column names and so on, right? So you can proceed by elimination also. Shall we have a look? What did you say? I have a majority here for this one, and some answered with the first or the last query, right? You can still change your mind. Majority is often correct, but not always. Well, in this case, the majority is actually correct. This was query number 2. Why not the first one? Because the first one doesn't change the name of the columns. It's ABD, but we want, if you paid attention, the second column in the output I want is E, right? So I need to rename the column as E. So this is why it can only be, you see it's E here. So it can only be the second or the 4th query, but not the first or the 3rd one. And the reason it cannot be the last one is the predicate. You see that the difference is B smaller than C or greater than C, right? But in that case, you realize it comes from the second row, and here B is smaller than C, right? And then 3 smaller than 4 might have been selected, but then if you add the end A equals D, then it's going to filter for just the second one, right? All right, and then you have this is unknown here. So B greater than C is unknown. It would have mean that you would have nulls in there. If you have a null, then it would be unknown. And that would actually filter the first row, right? Because B greater than C is unknown in that case because C is null, right? And here, A equals D is not unknown. That would actually take all of them because it's never unknown. A and D are always defined, so it's never unknown, right? So this is actually superfluous, but it's B greater than C here. That's why it's not this one. All right, so that's the what we did last week. So now let's go back to my slides and we'll take it from there. I'm letting Zoom do its thing, because if I touch it, then it might actually break. Yeah, it has the slides. All right. So, we left off with this slide last time that I told you that you need to be able to see the correspondence between a sentence in English that asks you to query something, the relational algebra with all these fancy Greek letters and formulas, the query plan that is just the abstract syntax tree of the relational algebra, but this is what the query engine can actually optimize and modify to make it more efficient in the background without changing the query semantics. And finally, SQL. What we've seen last time is select from where, just these three, but today we will see more. So we are going to expand this to actually more complicated queries. For whom is this select from where completely clear? Right? Okay, so we saw in the select clause, we do a projection, right, to the columns we want. And in the where clause, we do a selection, right? That might be counterintuitive, but the selection is in the where clause. All right. So now we are going to sort things. I told you that we have this semantics set, bag, or list. And if you adopt the list semantics, then you can have an order in the rows. It's actually quite convenient because if you look, for example, at spreadsheets, it's very common that you want to list either alphabetically or in a given order, right? So PostgreSQL supports this, the ability to sort the rows in a specific order with the semantics, the list semantics. And I'm going to show you how this is done in SQL. So let's take again this table that I had last time. So you remember that we have the name on the black background, the purple, these are the headers, the column names, the attributes. The yellow is the types. Remember, every column has a type because of domain integrity, right? So varchar is a string, char is one character, and so on and so on. And then we have the actual rows of the table. How many are there? How many records? 3, right? Okay, 3 records. All right, and by the way, even though we give the hint typically, when we ask for the number of rows in a table, it's always the records, the one in blue. We never include the attributes or the types in there. They are only here for the fancy display. All right, so this is what we can do now. If I have this order by clause, so I didn't put any where clause, just means that I'm not selecting anything, but I can order by birth date. And this is going to sort them in, by default, in ascending order. So you have first 2230, 2233, and 2324, right? So this is in ascending order of birth date, right? So this is, it's magic, right? All I need to do is say order by birth date, and that's it, takes care of it. I also can specify whether I want this ascending or descending. So by default, it's redundant to say that, but if I say asked it ascending, right? So the smaller ones, and then it goes up. This was the same, right? Because that's the default. But I can also ask in descending order. Then I'm going to start with the younger people, so 23, 24, and then it goes back into the past, right? So by descending birth date, right? It's so nice because this is just a line, right? It's almost like English, like order by birth date descending. That's a very intuitive way of putting that. Now, what about nulls? Because I might have nulls in there and I don't know how to sort nulls, right? I can sort integers, I can sort strings alphabetically, I can sort dates, but what happens if some of the values are nulls because you load them with the schema? Well, in that case, you also choose what you want to do with the nulls. And you can say, okay, the nulls, just put them first. Or the nulls, just put them last. So you can specify, if I say nulls first, and here I order by last name, then I'm going to have Spock first because the last name is null, and then I'm going to have all of the ones that exist in ascending order, right? For whom is that clear? Right, so I can specify this, and I can also say nulls last, then it just puts the null at the end, right? It's just a matter of how you want to organize things. By default, if you don't say anything, if you just say order by, it's ascending and nulls last. The nulls will be at the end. Then if you specify ask or desk, so ascending, descending, the nulls will be last, in the case of ask, and they will be first in the case of desk. What does it mean? It means that by default, the nulls are assumed to be larger than everything else, greater than everything else, right? So this is why last if it's ascending and first if it's descending. All right, so this is the default. And of course, you can also override this by explicitly saying ask nulls first or desk nulls last. Okay? Now, it actually gets fancier than that because I only gave you an example where I specified just the name of the columns I want to sort by, but actually you can also put fancy formulas in there. You can actually compute stuff that you want to sort by. And here I just came up with made up stuff, but for example, this double vertical bar, it's something that concatenates two strings. It's like plus would add two integers and double vertical bar concatenates the strings, right? So I put them on the left, Beverly Crusher, James Kerr, that's what you get by this. And then you would order by that, even though it's not in the output, that's your sorting criterion, right? And you see now it's basically ascending. And the null, by the way, absorbs, so Spock concatenated with null just gives you a null because you don't know the other part of the string. Okay. And that's it, and it's ascending, and the nulls by default are last, so this is all in order. For whom does that make sense? Right. Of course, this is completely made up. In reality, you can put whatever you want, and that's it will just be whatever you sort by. Okay, now, two more things, limit and offset. Before I introduce limit and offset, I think the simplest is that I give you the use case for that, why we have this. When you search on a search engine, Google, Bing, Yahoo, DuckDuckGo, and so on, you probably realize that it says on the top of the page, like 1,273,478 results, right? But it's not displaying all of these 1,200,000 results on the page, right? It's only displaying 10 of them, the first 10. And then if you click on next, it's the next 10. Then if you click on next again, it's the next 10. So 10 by 10. There's a name for that. It's called pagination. You have a first page, a second page, a third page, and you have 10 on each page. And this is very important because behind you could imagine a SQL query that actually does that. But what you don't want is to throw to the user the million results in a single table. Instead, you want to show the first 10. Then you want to show the next 10, the next 10, the next 10. This is what limit and offset do. Let's start with the first 10. Well, the first 2 in that case. There is this limit keyword that is going to just output the first 2. So if you order by birth date, it's going to be ascending by default. You don't output the 3 of them, just the first 2. So it's going to be Spock and James Kirk, right? So it's going to be the 22, 22. But Beverly Crusher, she's the third one. Since we said limit 2, it's not part of the results. Right. So this is very convenient if you don't want to crash your machine or you don't want to throw everything at the screen. Then just add a limit 2 or a limit 10 or whatever small number you have, and you're just going to see the first results. Very useful at the exam if you want to very quickly just peek at the first results to see that it works. Right? Super useful. All right. Always after an order by. It doesn't really make sense to use it without an order by because otherwise it's just going to be random, right? So order by and then limit. Then how do we paginate? Because that's the first 2, right? What if I want to go to the next 10, the next 10, the next 10? Then this is what offset does. Now, imagine that I do limit to offset 1. It's basically going to skip the first one and output the second and the third one, right? So limit 2 means I'm going to give you 2. But skipping the first one. So now you see it's just translated by 1. Spock is ignored because of offset 1. And now I have James Kirk and Beverly Crusher. All right? So now imagine that we want to implement a Google, right? How do I get the first page? The first 10 query results? Yes? Limit. Exactly, limit 10 or limit 10 offset 0, which is the default. How do I get the second page? Yes, over there? 2 of you were raising their hands. that could have been one way of doing that. So it's basically the design of the language, right? So you could have said that the limit and offset give you the bounds. So you ignore the first 10 and go to the 20th. The way that they designed the SQL language is that the limit actually is the number of the output and not from the very beginning. So that would be limit 10 offset 10, but you were not far away, right? It could have been designed in this way, that we say limit 20 offset 10, but it's limit 10 offset 10, all right? The second page. The third page, maybe you can try. You also raise your hand. The third page, what is it? Okay, somebody else, yes? Yes, exactly. Limit 10, offset 20, then limit 10, offset 30, limit 10, offset 40, and so on. So this is why we can paginate the results in that way with limit and offset. These are the magic keywords to organize your results in pages. It's super useful if you want to display the results to the user. Imagine you're an online shop, like, I don't know, Digitech, since I cited a few brands, I might as well continue. Imagine you're on Digitech and people are searching, they will see the first 10, then they click on next, and then you can use these offsets to just bring them to the second page, right? So super useful for a website if you want to have SQL behind it. All right. Okay. Now, what are the default values? Well, you already figured one out, that the default value of offset is 0. And the default value of limit, well, technically it cannot be a number because it's everything, but that's limit all. If you want to not have any limit, it's limit all. That's the default. If you don't say anything, it's limit all. Everything is displayed. Offset 0, meaning you don't skip anything, right? For whom is that clear? All right. Okay. Now, danger zone. What happens if I put this limit and offset and I don't put an order by? The thing is, if you don't put any order by, you're basically giving the freedom to PostgreSQL to do whatever it wants. Because it assumes that if you don't specify an order by, then you couldn't care less about the order of the results. So it's kind of a bag or set semantics, right? Set semantics if you eliminate the duplicates, bag semantics if you don't. So now what happens if you don't specify an order by and you get set or bag semantics, and then you say limit 2 offset 3? Well, imagine you're PostgreSQL and you're super lazy. Somebody gives you that query, limit 2 offset 3. And you know that you're not required to use the list semantics. You can think in the set or bag semantic. You might think, okay, let's do it by the book. They ask offset 3, so I just generate my results. I skip 3 of them and then give the next 2. But you can be lazier than that because you can think, okay, I need to return 2, right? Since I don't have to respect any list semantics and I'm free to order in any way I want, why would I bother with offset 3, right? I can just output any 2 that I want and that's it, right? So the first 2, and that works, right? So it's really, the idea here is optimization, being as lazy as possible to get the results as quickly as possible. So what would happen is that it would just throw 2 of them at you and it doesn't matter and you have no guarantee. For whom does that make sense? Okay. But again, danger zone, what I'm actually telling you is don't ever do that. Don't do that because this is probably not your intention to actually do something like that. If you use limit and offset, you really, really should do it together with order by. That's the only way that it actually makes sense and is going to do things in the way you want. Okay. Technically, I could imagine an exception. You could use limit without an order by, but the intention here is really that you're debugging and testing and you just want to peek into some of the records. Then that would make sense, right? You add a limit 10 at the end of your SQL query even without order by. And again, it's just in order to limit what's printing on the screen to not explode the computer, right? So that kind of is an exception. All right, so having said that, the danger zone thing, this is what we have now. Isn't that beautiful? Select from where order by limit offset. You make sure, please make sure to have it by heart. Know that by heart. Select from where order by limit offset. It's always in that order. You cannot change the order in which that is, right? Select from where order by limit offset. All right. Who already knows that by heart? Some of you? Nobody? Let's say it all together. Select from where order by, limit, offset. Exactly. And learn that by heart. I'll add some more, but this is already the intermediate clauses. All right. So we have the select from where order by, limit, offset. Now let's add more. Let's add the group by, its aggregation. Do you remember the gamma sign that I told you about? The gamma sign is this grouping thing. So here's the reminder. We have this gamma, we have a table, and we see that we have cities and countries. And we have, I don't know, let's say it's transactions with like people buying in the local shop, like at Coop or Migros or whatever. They buy something, they have some customer ID. And we want to aggregate all of that by city and country. How many groups do we have here? City and country. The colors are already there. It's 3, right? We have Zurich, Switzerland, Berlin, Germany, and Frankfurt, Germany, right? 2 for Zurich, 2 for Berlin, 1 for Frankfurt. So we're going to have 3 groups. This is country and city, right? Again, the ones that are just like on their own in the list, in the subscript is country and city. This is what we group by. The others are aggregations. I aggregate the prices with the sum, and I call it volume, and I count the customers with which I call non-transactions. What I get is 3 rows, right? 1 for each one of the keys. These are the sums. So this is this plus this. This here is this plus this. And this is just this. There's only 1. The count is the number of rows. 2 rows, 2 rows, 1 row. 2, 2, 1. For whom is that clear? Yes?
I have a question about aggregation. What if we have a 5th column, but didn't define it in the aggregation? Like, we don't know what to do with it. We just remove it and keep this.
Absolutely. So the idea is that you might have more columns in the original table and you don't include them at all in the output, and that's totally fine. You can absolutely drop them. So typically there are 3 things you can do with the column. Either it's a grouping key, or you aggregate on it, or you drop it. That's basically it. You could also aggregate the same column in different ways. You could aggregate with a sum and then aggregate with an average in another new column and so on. That's totally fine, right? The one thing that you should not be doing is to have a column both in the grouping keys and in the aggregations. That's a bad idea. It's probably not something you want to do, right? But apart from that, you can ignore columns, you can aggregate multiple times on the same column and so on, right? And you can actually play with this with the SQL. Yeah. Okay. All right, let's do it in SQL then. So there's this new group by clause, century. I say group by century. What I put in group by is basically the ones that are without aggregation. So country and city would be right here. Group by country and city. So I put that in the group by. And then in the select clause, I say what I want in my output, the full list. So century, I repeat it. It's the grouping key. I also put it in select to include it in the output. And count is basically just counting all of the rows, right? So it's just saying how many rows are there in each group, right? That we didn't have here because it's the star, it's the joker, right? That's an extra thing we get in SQL. It's just counting all of the rows. So now it's going to output. Let's look at what happens. Century, group by century is here. How many different values do I have? 23 and 24, right? So 23, 24. Now this count star, we count the number of rows with 23. There's 1 here and 1 there, 2. And how many rows with 24? 1 here and 1 there, 2. I could also have said count of original series, count of last name, count of middle initial, count of first name. You know, I could actually have counted any column, right? Technically, it would have done the same thing. But what is very common in many, many cases, people just say count star, and that's it. And it gives you the number of rows in every group. For whom is that clear? For whom is that not clear? Who is asleep? No. Okay. So I assume this is clear, right? All right. So count star. Now you probably noticed that you didn't give it any name here, because here we had also a row with a new name, right? We call it volume, we call it non-transactions. Here I didn't do anything, so we just called the column counts in the same way, just made up a name. Yes? Yeah. Yeah, absolutely. So the question I'm repeating for the people on Zoom, why this begin thing in my results? So technically, this column with the counts is just popping out of nowhere, right? I'm just counting records and I'm creating that new column with the number of records, like count star. There is indeed a default behavior, you're absolutely correct. In that case, PostgreSQL is just going to pay begin because that's the largest it can actually figure out, right? Again, you can go all the way to 16 quintillions. So I think it's very unlikely that you're going to have more than 16 quintillion records in a group if you use it on your local machine. So absolutely, it's begins, and this is what you will get if you do it in PostgreSQL, right? For the counts, it does that. All right, you can also give a name explicitly to your column if you have, say, as counts. Here, I just give it the same as the default name, but you can call it whatever you want. What is very important to understand is there are the grouping columns, there are the columns on which you aggregate, and there's the columns you ignore, right? So the grouping columns, where do I put them? I put them in the group by clause to say that it's a grouping column, plus again in the select clause. You don't have to, but you really should, right? So you really need to put it here and here. Otherwise, strange things will happen. So here and here for the grouping column, and like here, group, century, and count. And the non-grouping columns, these are the ones that either you can drop. In that case, I actually dropped all of them and ignored them and just had my count here. But in general, you can actually also, let me show here, put one of the non-grouping columns as a count right here. But I had, just going back, I had this, what you shouldn't be doing. This is a no-go. Do not ever put a non-grouping column, so one that is not in the group by, never put it on its own in the select clause. Do not do that. Here, H is on its own in the select clause, but it's not in the group by. Do not do that. The problem, here's what the sort of strange things that are going to happen. You group by centuries, you have two groups. Then what do you put for the H, right? For 23, for example, you have two possibilities. Do you put 57? Do you put 189? You don't know, right? It's weird. You should really aggregate. You should use a sum, a count, a mean, a max, or something. But that you really shouldn't be doing, okay? So the grouping keys go into the group by and the select. The non-grouping keys must always have an aggregation with them. Like this, I have a count, that's fine. Now I count the number of ages and I get 2 and 2, right? Technically, until now, so far as I explained it, count star and count H do the same thing, right? They count the number of records. There is a tiny difference between count star and count with a column. It's that if you count with the name of a column, it's gonna ignore the nulls. That's the one difference. If you say count star, like the one I showed you before, count star is really counting all of the records, doesn't care if there's nulls or not nulls or whatever, it just counts the records. If it says, if you say count H and there happens to be nulls in there, it will not count them. If there are nulls in the H column. For whom is that clear? Right? Okay. So this is really, I would say in 80% of the cases, you're going to be using count star. And in the cases that you want to eliminate nulls, then you would use a count on the column. Yes?
Can you go back to the side of count H?
Yeah, this one. Count H. This?
Yeah, 1, 4.
This one?
Yeah. What is happening there when you count the H? You get like 4A, 2, and 4, 2 times 2. What are you counting? I mean, you have 4 different H's.
Oh, there is no notion of distinct or not. We are just counting rows. So technically, what happens is, I'm going to be now the computer executing that query. We group by century. So this is the column. How many groups? One group with these 2 rows and one group with these 2 rows, right? So we have one group, one group. What do we put now in there? We look at the groups one by one. The first group, 23, there are 2 records. Now I'm looking at H. I'm looking at the non-null values. How many non-null values are there? There's one record here with a value that's not null, and a second record here with a value that's not null. That's 2 of them. So I put a 2 in there. 24, I have 2 records. how many of these records do not have a null? There's one record here that doesn't have a null, one record here that doesn't have a null, so I put 2. Now you might be asking, what happens if 2 have the same age? It's still counted as 2 different records. You don't care if the values are equal or not equal. You're always counting the records, counting the rows, right? There is no distinct elimination whatsoever. Does it answer your question?
Yeah.
Yeah, awesome. And so if you had a count star, then it wouldn't care about nulls. But if you have a count on a column, it will only count the number of records for which there is not a null in the column. Okay. All right. But again, most of the times people do this. This is the one query that people do all the time. This count star is 80% of the cases. All right. Okay. So now here's another example, 23. Yes, that's to show you the nulls. So now let's execute that query. What's my grouping key? It's century right here. And I have 2 groups, one group of 2 records, one group of 2 records. Now I aggregate middle initial. Where's middle initial? It's right there. So I aggregate this. Let's look at my first group, the 23. How many records do I have such that the middle initial is not null? How many? Not null, right? Just 1. It's this one. This one I don't count because it has a null in there. So I put a 1 in here. And then 24. How many records does have a middle initial that is not a null? Just 1. So I put a 1 in there. If I had count star, that would have been 2 and 2, right? But count middle initial, you see the nulls, they go away. Right? They are ignored. That's the difference when you have a count on a column. Okay? And with the star, it would have been 2 and 2. And by the way, here I also renamed it to give it a name, right? As A, and I call it A. But it's always going to be a big list of few counts. Okay, so far I showed you with the counts, count star and count on a column. But there are other aggregation operators that I already told you last week, right? We have sum, we have mean, we have max, we have average. So there are several that we can have. These are the most common ones. My advice for you, learn these 5 by heart. It's a list you must know. Max, mean, sum, average, count. These are the big 5. These are the most often used aggregation operators. Max, mean, sum, average, count. Sum, average, you typically need numbers. Max, mean, anything that's sortable, like strings would also support max and mean. And count, anything. You can count anything you want, okay? But there are others. They are just less well known. There's a full list of, it's called aggregation functions, and you will find them in the documentation. You can aggregate Booleans with an AND or an every. You can aggregate Booleans with an OR. You can aggregate strings. So you have all of the strings and you concatenate them to a big string with string tag, right? So these are the advanced ones, but really the ones that people use all the time is max, mean, sum, average, count. I have a very good question on Zoom that I don't know the answer to. Do you want to look into it, Owen, if you have a Jupyter notebook, to try to see if you can compute the, like make up a table with some nulls and see what the average does? I don't have the answer to this, I don't know, but we can look it up. The nice thing is that since it's practical, all you need to do is to just open a Jupyter notebook and try it out. So we'll see, maybe we will know in a few minutes the answer to that question. All right. Okay, so again, by heart, max, mean, sum, average, count. These are the typical 5 that are used most of the time. Okay, so let's use them. What happens? So here I'm going to aggregate by century and I want the minimum age. So the minimum age is going for the 23rd century, it's 57. The other would be 189. Yes, that's how long they live in this century. So 57 and 189, and the mean is 57. So I put 57 in there. And for the other group with century 24, we have 35 and 41. So the minimum is 35. Who understands how this output is computed? Please raise your hand if you do. Just checking you're following. Okay. On Zoom too? Do you understand on Zoom what's going on here? We'll go to the question right after that. On Zoom, is there anybody listening to us and awake? Can you raise your hand if you understand what I'm telling you? Yes, okay. Wonderful. Now there was a question, Bowen, about mean.
The question is it possible to use mean star?
I think not. If I'm correct, you can't. The star is just with count, because you can count records. If you do mean star, you basically want to compute a minimum record. But in order to compute a minimum record, you would need a way to order the records. But there is no one way to order the records, right? It's basically why we have this order by clauses. So I think that mean star doesn't exist. It's really just count star. Right. Then we have max. Max is the same thing, except that now I take the higher value. So 23, the max is 189, and for the 24th century, the max is 41. Okay. The sum then, for 23, we have 57 plus 189, gives me 246. And for the 24th century, the sum 35 plus 41 gives me 76, right? Then I have the average. I don't have any nulls here, so I don't have to worry about the other question. So the average of 57 and 189 is 123. And the average of 35 and 41 is 38, right? So this is what we get. Now, let's look at the type, because something happened here. Minimum, I have a type integer, and h had a type integer. So typically, if you compute a minimum or a maximum, it's going to preserve the column type. So it's just taking over the type of the h column and keeping it, min max. Sum is also going to do that. It's going to just add an integer with an integer. You might have special cases in case that you add two integers that are smaller than 256, for example, and you add it to another integer lower than 256, that might actually give you something higher. So it might be that with the sum, the type of the column might also change, right? But here I have an integer type, so it just preserves it. The details of that is really the documentation. Different engines might have different conventions, but in that case, this is what it does, right? I have a type integer, I sum two integers, and I get another integer. Now something happened here. I'm computing the average of two integers, and I'm getting a numeric. Numeric basically accepts decimal numbers, right? That's the type for decimal numbers. Why, when I compute the average of integer, why did we change the type to numeric? Anybody can guess? Why did we change the type here? Yes?
Because when you divide the type,
Yes, exactly. So if you compute, let's say, the average between 1 and 2, that's 1.5, right? So it's not an integer. So because in general, the average of several integers might not be an integer, we had to change the data type to numeric. Here we were just lucky. It was the average of two odd numbers, so it gave you another number, right? But in general, it could have, it could be a decimal value. All right? Okay, and here it's just for showing you something advanced, but it doesn't matter if this is not entirely clear. It's just a Boolean end. So here I have these Booleans. I've just changed a little bit the table, and I have these Booleans, true if it's a captain, false if it's not a captain. Boolean end just computes an end, a logical end. So for example, 23, I have true and false. So true and false is false. That's the laws of logic. So I put a false. And for 24, I have a false and a true. So I compute false and true. That gives me a false, right? Bool end would only output true if everything is true. If everything is true in a group, then it's going to output a true and otherwise a false. Then I have bool or. Bool or is going to output false if everything is false, and if there is at least one true somewhere, it outputs true. So here in the 23 group, there is a true, the first record. So I put true in there for Boolean or, and in 24, there is a false and a true. False or true is true, right? I can also use string ag. For example, here I want to aggregate the first names and put a comma in between. So I see James, comma, Spock, right? and then I see Beverly, comma, Catherine, right? That's yet another way to aggregate. Okay, who is following? Okay, awesome. So again, the big five, mean, max, sum, average, count, these are advanced, a Boolean AND, a Boolean OR, a string aggregation, and so on. These are more advanced, and then plenty of others in the documentation. Okay, but it's really the big five you have to know. Okay, so now I'm repeating something I already said, so you can have multiple grouping keys, right? But everything you have in the group by must also go into the select. Must, my advice, right? So Century and Captain are in the group by, thus they should also go in the select clause, right? And then in the select clause, you have the grouping keys plus all of the aggregation. If you don't, like here, I didn't follow my own advice. But do you see that here it's weird, right? You have a Century, you have groups, but now you have 24 and 24 associated with a 1 and a 2. The reason here why it's strange is that we didn't have the Captain column in the output. We just didn't include it. So this is really something you shouldn't be doing that. Do not do that. Do not omit some of the grouping keys in the select clause because then the output is difficult to understand. Always make sure that all of your grouping keys in the group by are also exactly in the same way in the select clause, right? Okay, that's the group by clause, right? That's the gamma. Now, there is another clause that is called having. Technically, having is the same as where. It's just the sigma Greek letter. So it's the same as where. The difference between where and having is that where is before the grouping and having is after the grouping. Where is a selection before the grouping, having is a selection after the grouping. So because it's after the grouping, in the having clause, you are allowed to use aggregations, right? So for example, here, I'm saying group by century, but only keep these groups that have a count strictly greater than 2. I changed the data in there. Of course, I made it interesting. So 23 now only has 1 record and 24 has 3 records, right? So how many groups do I have with more than 2 records? Just 1, the 24th century. So now I only have the 24th century, right? So this is what the having clause does. It's a way to filter things out, to select records, but after the grouping has been done. This is why I can use my counts in the having. In the where clause, I couldn't put the counts because the where clause doesn't know anything about the groups. It's before the grouping. That's why it has to be in the having clause. So this is now, if I draw this as this abstract syntax tree that I told you about, when I have a query like this, I basically start with from, then the where clause performs a sigma, a selection, then the group by is a gamma, then I have having that is again a sigma, but after the group by, and then the selection is a pi. Right? So this is really pre-grouping and post-grouping, where is before and having is after, but both of them are really sigmas. Okay? So this is what we do here. This is the same thing. Usually what people do is they draw it like this, in vertically, the way. So you have the result is at the top, the table comes from the bottom, and then it flows through the operators like this. Okay, here I'm just repeating some best practice advice. Have the habit of renaming the aggregated columns. Whenever you aggregate with max, min, count, and so on, please rename the columns with as, right? Second, all the grouping columns, include them in the select clause. Do not omit one of them. Always include them. Then you should also have at least one aggregation. If you think of it, when do you not aggregate anything, right? If you only want the grouping keys without any aggregations, you're just doing a duplicate elimination because you're only looking at the groups and the keys. But in that case, you can just say select distinct. It does exactly the same thing. Do not aggregate the grouping columns. Always aggregate the non-grouping columns, those that are not in group by. And then do not use having alone. Having only makes sense with the group by. It's like the limit and offset that should be used with the order by, right? So having is really together with group by. I'm going to stop here before the break with the reminder that this is now what we have exactly in that order. Learn it by heart, select from where, group by having, order by limit, offset. By heart, it's always in that order, okay? You see, we've done a lot. Now you know all of that. So let's take a break. I think that, that you deserved it. So I'll see you in 15 minutes at 11:15, and then we'll look at more advanced things. Thank you very much.